We tried to do something a bit smaller. We're going to take down Uber with our mobile application. It's called DFaST, for Decentralized Fair Shared Transportation. We're going to start with a little demo of how the application works that Arthur put together. Let me start it here. So what you do is you connect your wallet to the app, you log in, and you set your destination where you want to go. Drivers get a notification and can place an offer for your ride, and you can pick from the listed drivers who you want to take you to your destination. At the end of the trip, you both end the ride by submitting a transaction, and that's that. Of course, there's a lot more to it. So let's get into it. Hello, Arthur and Lino, our coding geniuses, as well as Carlo and me for team spirit and a bit of presentation and design. Here's our problem. The rideshare industry is huge. We all take Ubers from time to time, and there's a bit of dissatisfaction, right? Riders are getting, the rides are getting much more expensive as the companies are increasing the fares. At the same time, the drivers are getting annoyed because the fares are going up, but so is the share that Uber is taking. So their fee is not really increasing. Then there is a problem with centralized arbitration, if you will, where drivers just get banned from platforms without transparency or any right to defend themselves. And lastly, we think this application could actually lower the threshold for a non-Web3 native audience to start using Web3 based applications as soon as they realize that their drivers are earning a more fair fee, they're paying less, and it's just all more fair and contributes to a better world. So this is what we're presenting. We're cutting out the middle company between riders and drivers. There's going to be trustless, decentralized route calculation for impartial, fair, and transparent ride pricing. For that, we're using the OSRM and enabled by Cartesi Rollups. Ride requests with ephemeral ID and use of geohashes for origin and destination areas to improve privacy for the riders. And a zero knowledge-based reputation system to keep drivers and riders privacy using Aztecs and Wire. Yeah, you can guess the map. That's a fun game. So first, Carlo, please help me out with this list because this falls out of the scope of Team Spirit.
No worries. So I'm going to detail a bit how the actual process of getting a ride works. So the first thing that happens is when you want to go to point A, from point A to point B, you don't disclose this on chain. Otherwise, people can just look at all the transactions that are happening and can figure out, oh, this guy comes out of his house 9 a.m. every day and goes to work at 5 and then comes back to home and all this kind of stuff. So in order to keep some level of anonymity, what happens is besides using these ephemeral IDs for every trip, we also make the least amount of data available on chain for that trip. So how do we do that? The first thing the client does is when you say, I want to go from point A to point B, they go to the Cartesi machine and they make an inspect that's backed by this OSRM routing service. It's a really big open source project that does routing equivalent to what Google Maps or Waze do. And when you get this detailed route from point A to point B, you do a request on chain that has a signature representing that detailed route, and you actually put a geohash with 6 characters, if I'm not mistaken, of precision, saying what's your origin and destination. These 6 characters of geohash pretty much define a neighborhood. So what you see on chain is someone is coming from neighborhood A and going to neighborhood B. So that, in our opinion, is enough for drivers to say, hey, I'm interested in that. And they also see the value in the distance, that's the detailed distance that's going to go there, and still enables privacy for users. When you put this on-chain transaction, say I want to go from neighborhood A to neighborhood B, this is the price and this is the distance, all the drivers, they can bid on it. So they can say, hey, I can take you, I can take you, I can take you. And then the client receives all these bids. And along with it, it gets a reputation of the driver, and it's still anonymous because Lino made this really complex zero knowledge based scheme in which he can export and import reputation while keeping privacy. And once you choose your driver based on his reputation, the amount of trips he's done, you go on chain, you agree that you're going to take him as your driver, and you actually give him the full detailed itinerary. And then the driver with the full detailed itinerary can always go back to Cartesi, check that itinerary is the one generated from point A to point B, and match the signature that was on the initial request. Yeah, I guess that's the flow.
Then let's jump to a quick demo, Carlo, of what you just explained. So this is how the routing process. There we go.
So this is just a show of what's going on the terminal in a simple test that stresses the inspect to OSRM. So in here, we're doing a simple request going from Rio de Janeiro center to Botafogo. And then we have the Cartesi machine answering the route that was provided by OSRM. So it's a full route detail, what you get on Waze or Google Maps, same stuff, all the turns, all the street names, everything is in there. Let's now detail a bit more on this zero knowledge process for the reputation, and Lino's gonna go through it.
So this version, all the drivers, they can change their wallet, but well, they keep their own reputation. Obviously, this is just for the driver. This could be extended for the rider, but at this point, it's just for the driver. So the way that we do, when the driver wants to change his account, he generates a zero knowledge proof that proves that a submitted hash was done using a secret and also using the reputation. And when he submits this hash, it's included in a Merkle tree, which later he can prove using also zero knowledge that he owns a secret that belongs to that tree. So in this way, he can import, he can change wallets while keeping some the data that resides inside the Cartesi machine. So yeah, this is a simple Merkle proof verification, and obviously this can be extended to also the payment system. So everything can be anonymized as well. So there's a small demonstration of the circuits that run using Noir. So this is the two circuits just to prove submit the reputation, to export the reputation, and then to import again using the Merkle verification.
All right. Thank you, Lino. So after we're taking down Uber, obviously we're going to go for Bolt and all the other apps. But before that, we got a few minor updates. So we got a ZK-proof based payment system, as Lino already mentioned, to help the privacy of the drivers and the riders. We want to allow driver and riders to direct message each other using the XMTP protocol. Implement ride price multiplier that reacts to weather conditions using the Chainlink Oracle to fetch the weather data and periodically trigger automatic updates into the application. And of course, a DAO for conflict resolution. So ending this presentation, I don't want to bribe the judges, but I just want to say if there's going to be like an after party to this day of presentations and hackathons, we might be able to provide all of you with some free DFaST transportation. So just want to put that out there. Let me know if we won first prize. Thanks, guys. See you later.